Okay guys, so now we're going to talk about specific ideal gas laws, and the first one that we'll talk about is Boyles Law. And Boyles Law states the volume of a gas at a given temperature and number of moles varies inversely with the applied pressure. So the way that I remember Boyles Law is if you boil water, the temperature stays the same. And in all these, except for Avogadro's law, the number of moles will stay constant. So here, if you increase the pressure, you are going to decrease the size of the container if it's a flexible container. So the volume of the gas will shrink. And so mathematically, we say PV, or pressure and volume, is equal to a constant. So they have an inverse relationship. This constant here, notice, will stay the same. The constant will stay the same. So if you increase one variable, the other one has to adjust or go down to keep that constant the same. I think an easier way of looking at it is if you are changing conditions and how you would work that mathematically. So here we say P1 V1, okay, is equal to P2 V2. So if you start with a given pressure and volume, and if you increase the pressure, then you can calculate the volume, the new volume of the gas. And so we'll do an example of that here in a minute. Okay, so here's our example. What is the volume of 40 milliliters of gas at 1.5, that should read atmospheres, if you increase the pressure to 3 atmospheres, temperature, number of moles being constant? So let's work that one out over here. So I always think it's helpful to write down your variables as you go. So what is the volume of 40 milliliters of gas? So that would be V1 would be 40 milliliters. And then a P1 would be 1.5 atmospheres. And then you have here, it says, if you increase the pressure to 3 atmospheres, so that would be P2, be 3 atmospheres. And then what would your new volume be? So that would be V2. Okay, so you just plug those in and solve. So it would be 40. I always think it helps to go ahead and write your units down as well. 1.5 is atmospheres there, is equal to 3.0 atmospheres times X, which will be our volume. So then that just becomes 40 milliliters times 1.5 atmospheres divided by 3 atmospheres. Atmospheres cancel here, and our final answer here will be 20.0 milliliters is our final answer. Okay, so there is a Boyles Law type of problem.